So whenever I square the number, something to the square, and it gives me an answer, that answer is a squared number. We call that a squared number. So the ones that we have seen so far, so the 1 squared, which is 1, 2 squared, which is 4, 3 squared is 9. So the 1, 4, 9, 16, 25, 81, these are called squared terms. Okay? They're called perfect square. So a number is a perfect square. If when square rooted, then you can get a whole number. Okay? So if I take 9 and I square root 9, what do I get? 3. Right? It's a whole number. Now, is 24 a perfect square? Is 24 a perfect square? It is not. Right? Because if you take the square root of 24, it's going to give you a decimal. Okay? So it is not a perfect square. You're going to have to recognize these perfect square, and we talked about them. They're 1, 4, 9, 16, 25, 36, 49, 64, 81. Like, these are the numbers that you're going to commonly see. These are perfect square, because if I actually square root them, they're going to give me a whole number. Do you guys understand that? Now, these are the numbers that are perfect square. How do you know if a letter is a perfect square? How do you know if a letter is a perfect square? So for a letter to be a perfect square, your exponent has to be even. So if you have an even exponent, that's considered a perfect square. Okay? So an example would be x to the power of 2. That's a perfect square. Or y to the power of 8. Or z to the power of 4. Anything with an even exponent is considered a perfect square. Are we okay with that? Okay. So if I have one of these perfect square letters, and I want to square root it to find the answer. Okay? So if I want to square root an x to the power of 8, okay, what happens is you divide the exponent by 2. So here's the thing. If I have square root of x to the power of 8, then it's x to the power of 4, because what I have to do is I divide 8 by 2. Okay? So, give me an even exponent. M to the power of, give me one. Even. 14. If you want to square root that, what do you get? M to the power of 7. Okay? Because to find the square root of that, you divide your exponent by 2. Is that clear? Give me another even exponent. B to the power of, give me an exponent. Even. 8? We just did 8. 6. If you want to find the square root of that, what would it be? B to the power of 3. Okay? If you have x to the power of 2, and you're square rooting that, what are you going to get? X to the power of 1. Okay? Because 2 divided by 2 is 1. Are we clear with that? Okay. So, we need to know how to recognize perfect squares. Okay? Because our next factoring deals with perfect squares only. Okay? We call the next one difference of squares. Okay? So let me highlight this for you here. Difference of squares. This is a term that you're going to hear from me often. Okay? What does the word difference mean in math? Like if you're translating difference to math. So it's a subtraction. Difference is subtraction of square terms. So you're looking at two square terms that are subtracted from each other. Okay? So when you're looking for different squares, you're looking for a binomial. Bi means 2. So you're looking for two terms, perfect square, that are being subtracted. Two terms, they have to be perfect square, and you're subtracting them. Okay? So here's what you need to look at. Anytime you have a binomial, two terms, you're going to look at if they're perfect square and there's a minus between them. Let's look at this one. I have 9x squared minus 16. Is 9x squared a perfect square? Yes, 9 is one of my perfect numbers, right? And x has exponent, even exponent. Is 16 a perfect square? Yes, it is. Because if I go back here, I have 1, 4, 16, 25, 16 is one of them, right? If I square root 16, it's going to give me 4, right? So perfect. So that's my first check mark. So both terms are perfect squares. Do I have a minus between these terms? That's my second check mark. So anytime you're going to do the different squares, in your brain, in your head, you're going to have to do these check marks. Okay? Now let's see how we are going to factor it. Because remember, the whole goal of this is to factor. To factor this perfect square or difference of squares, first you're going to write two brackets. Okay? You're going to right away set up your two brackets. In the first bracket, you're going to put a plus, and then in the second bracket, you're going to put a minus. I'm going to show you multiple steps, so this way you get used to it, but at the end, you're only going to write my final step, your final step, okay? But I'm going to show you how in your head you should be seeing this. You should be doing this. Now, in the first position, you are going to take the square root of your first term. So you have your first term, you're going to square root that. What's square root of 9x squared? What's square root of 9? 3. What's square root of x squared? X. So it's going to be 3x. So you're going to put 3x in the first position in each bracket. Then for your second position, you're going to put the square root of your second term. What's the square root of 16? 4. So you're going to put 4 in the second position. So you're going to end up with two brackets. They have the same terms. One is positive, the other one is negative. Okay? So what I want to see from you, technically, is this only. Okay? These steps is just for me to show you what happened. Okay? So, do we understand that? It's going to take more practice to get used to it. Okay? Here's a question for you. Example 2a. Is it a perfect square? Do you have two perfect terms? X squared is a perfect term. 25? Is there a minus between them? Good. So can I use difference of squares? Good. So I put an equal, open brackets, plus in the first, minus in the second. What's the square root of the first term? So if I square root the first term, it's going to give me x. I put it in first position. What's the square root of my second term? 5. I put it in the second position. And I'm done. So you see, I showed you my thought process here, but I didn't actually write it down here. I just did it step by step in my head, and I showed it to you on the board. Okay? Is my second question a perfect square? Difference of squares, I meant. I keep saying perfect square. Is 16x squared a perfect square? Yes, 16 is a perfect number. X squared is even exponent. Is 1 a perfect square? Yes, it is. 1 is a perfect square because 1 squared is 1, right? Is y squared a perfect square? So I can use difference of squares. Is there a minus between them? Plus minus square root of 16x squared is 4x. Put it in first position. Square root of 1y squared is y. Just y. Or 1y, right? But you don't have to write that one. Okay? Try the next one.